A Rail Operating Center, ROC, is a building that houses all signalers, signaling equipment, ancillaries, and operators for a specific region or route on the United Kingdom's main rail network. The ROC supplants the work of several other signal boxes which have thus become redundant. Network Rail announced the creation of 14 ROCs situated throughout Great Britain that will control all railway signalling over the British National Rail Network. This was subsequently revised to 12 ROCs with responsibilities at 2, Salt Lake and Ashford, being transferred to other ROCs, Rugby and Gillingham respectively. In November 2016, Network Rail announced that the ROC at Edinburgh would not go into operation with all its functions and responsibilities being transferred to Colliers in Glasgow. Nationally, this has meant the removal of 800 mechanical lever signal boxes and around 200 panel and IECC boxes. Some are listed buildings and will be left in situ. The ROCs are built under private contracts for Network Rail and will only control the rail routes controlled by Network Rail. Railways in Northern Ireland, various heritage railways and other tramways are not subject to control by a ROC. Ashford IECC still controls the UK stretch of the Eurotunnel rail link, HS1/control. The ROCs function as signalling and control centres with signalling staff, train operating company, TOC, staff and network rail controllers all working under one roof. This is meant to enable quick solutions to signalling problems and fewer delays to trains and passengers. Network Rail envisaged the 12 ROCs to be controlling the entire network by 2058. Originally, the early railways employed policemen to time the intervals between trains and to give a stop signal if a train had passed in the previous 10 minutes. Developments led to many everyday workings, such as interlocking points and signal boxes to house the levers that allowed signalers to change the points and signals over a given stretch of railway. These signal boxes were often elevated above the railway due to the locking mechanisms of the signals and points being accommodated on the lower story. This also allowed the signaller to keep an eye on things from a good vantage point. At the end of the Second World War, the United Kingdom network was host to over 10,000 mechanical lever signal boxes. When British Rail was created from the Big Four private railway companies under the Transport Act 1947, they began to install power signal boxes, PSB, at strategic locations such as Euston, Crewe, Doncaster, Rugby, and Carlisle. The PSBs would remove the necessity for many individual boxes along a particular route and would pass control to one centralized location. Carlisle's PSB took over the responsibility of 44 signal boxes alone in the northwest area. A step on from the PSBs was the IECC, Integrated Electronic Control Center, system, a forerunner of the ROCs. The first IECC panel was installed at London Liverpool Street in 1989. After the railways in Britain were privatised in 1994, staff from the then operating company, Railtrack, paid a visit to the Union Pacific Operating Center, USA in 1999. After viewing the facilities and seeing the control, they decided that a handful of major operating centres was the way forward for UK operations. Just one centre was approved and built in 2003 at Salt Lake, near to Birmingham, as part of the West Coast route modernisation. However, this building was not connected for some time, and whilst it was used by Network Rail staff, no signalling equipment was installed until 2006. With the advent of the Digital Railway project, signalling methods such as ERTMS have been adopted as a way forward by Network Rail. There are two components of ERTMS, ECTS, European Train Control System, and TMS, Traffic Management System. Whereas line-side signals operated by a signaller would control train movements, ETCS will signal trains via a computer without line-side apparatus. In effect, the train creates its own buffer zone through a digital signal transmitted from the cab. An onboard computer on the train will inform the driver of the allowable speed and movement of the train. TMS allows delays to be minimized through a computer running algorithms and deciding how best to return traffic patterns to normal. These systems mean the removal of traditional signaling infrastructure and the signal boxes that go with them. York IECC, Integrated Electronic Control Center, is an example of an early version of a ROC. York IECC was opened in 1989 and controlled a large region in Yorkshire bounded by Gargrave, South Emsall, Selby, North Allerton, Cottingley, Leeds, Bromley, and the Harrogate Loop. The ROC, which opened in York on September 12, 2014, superseded the York IECC in January 2015 and will eventually control the East Coast Main Line and associated lines in Lincolnshire, Yorkshire, and the Humber and the northeast of England. This means a King's Cross to Edinburgh train will be signalled by York ROC all the way from King's Cross to the Scottish borders. Salt Lake ROC will become a remote signalling centre of Rugby. The facility at Salt Lake was opened as a bomb-proof signalling centre for the West Coast route modernisation. However, the inability to achieve a workable traffic management system, TMS, without line-side signalling, meant an increased budget of £1.4 billion and the building became a white elephant. The structure was slowly integrated into an ROC function with signalling upgrades transferring responsibility to Salt Lake starting in 2006. Because the interlocking mechanisms are in place, they will be left at Salt Lake and operated remotely from the Rugby ROC. What Salt Lake cannot do, that Rugby can, is host the human space needed for the signallers and train operating company, TOC, staff to work together. In 2011, Network Rail forecast that 40% of the then remaining 845 signal boxes would be closed by 2017. Progress on this has been slower than anticipated and, by the end of 2017, 137 signal boxes that were due to close were still open. Whilst the drive for the ROCs has been one of signalling upgrades, there are other benefits and detractions to the scheme. Around 4,000 staff will lose their jobs over the course of the implementation program, leaving 2,000 signallers in the ROCs. The benefits of centralized control will be that the train operating company, TOC, staff will work alongside the Network Rail staff to allow cohesive problem solving such as resolving late running and last-minute platform changes. Network Rail have said that the ROC is a key part of our strategy to improve reliability whilst driving down the cost of running and maintaining the railway. In 2016, it came to light that Network Rail had been hacked 4 times up to July 2016. As most of the rail network in the United Kingdom is analog, it would not affect anything, but Network Rail have an aspiration for the digital rail traffic management system to go live in 2018. An online security company, who are not commissioned by, or who work for Network Rail, discovered the hacks and declared that whilst the hacks were probing and not disruptive, they could well be full of malicious software in the future. Network Rail clarified by saying that Britain has the safest major railway in Europe. Safety is our top priority, which is why we work closely with government, the security services, our partners, and suppliers in the rail industry and securities specialists to combat cyber threats. In 2017, Ian Prosser, the Chief Inspector of Railways, informed the Transport Select Committee that not enough had been done to alleviate the possibility of the ROCs becoming a single point of failure. Prosser highlighted higher workload on signallers and the contingencies needed in the event of a natural disaster disabling one of the ROCs. ROCs are mostly referred to as rail operating centres. Even in Network Rail's own documentation, they are sometimes referred to as railway operating centres. Some of the railway press have referred to them as route operating centres and even regional operating centre. This issue is further clouded by Network Rail having another ROC, the Railway Operational Code, in the signalling industry in the United Kingdom having a remote override control.